Good day, everyone. Welcome once again to your study part. In today's class, we'll be looking at the next aspect of physics, which is mechanics. Remember, I told you in the previous class that subject to your Jamb preparation, you have to consider the 6 key aspects of physics, talking about mechanics, heat and temperature, wave, electricity, magnetism, as well as atomic and nuclear physics. So, the last class we were able to look at electricity in its simplicity, talking about capacitor, talking about resistor, among other things involving electricity. In today's class, we'll get right into the business of looking at mechanics, and we'll be looking emphatically at the topic motion. We'll be considering to what extent Jamb can always bring out questions involving motion. And this involves understanding the various branches we have under motion and how it relates to your Newton's equations of motion as well as Newton's laws of motion. Let's get right into it. First up, what is motion? We define motion as the visible change in position of a body from one point to another. Imagine if I'm to be here now and the next minute I'm at this point and you didn't visibly see me change my position, you don't regard that as motion. We define motion as the visible change in position of a body from one point to another. Understandably, you already know that we have various types of motion which you could be asked questions on. The first being translational, or linear motion. Translational or linear motion. The second being random or zigzag motion. The next being oscillatory or to and fro motion. Number 4, we have circular or rotational motion. We have the fifth one, which is most times not referred among the general 4, and that involves relative motion. Relative motion. So let's get into it. First up, translational motion. We define translational motion as the type of motion which involves what? The movement of a body along a straight line, along a straight path. We have what? Linear or translational motion as the motion of a body along a straight path. Pushing on, we have that a boy running along a track is considered as a linear motion. A train that is moving along a given track is considered as linear motion. Example of linear motion. Talking about random or zigzag motion, sometimes you see Brownian motion also mentioned with this regard. This is what? A directionless type of motion, and a typical example of random motion will fall under the movement of a butterfly. So remember that Jamb under this aspect will give you an example of a type of motion, and they expect you to specify correctly exactly under which of the types of motion you have that type of example. So the motion of a butterfly is a typical example of a random motion. Also, the movement of smoke from a burning item is a typical example of random motion. Why? There's no specific direction to which the smoke would what? Move. Don't forget, when you spray your perfume in a room, the movement of the molecules of the perfume in the room is a typical example of random motion. Why? You spray the perf here, over time, it tends to spread across the room, and people in the room at the other end of the room get to perceive the odor. So as such, random motion, we define it as what? A directionless type of motion. Furthermore, number 3, emphasizing on oscillatory motion. This is generally referred to as to and fro motion, back and forth motion, moving front, back and forth, back and forth. A typical example which you are going to see in your physics past question, talking about your Jamb preparation, would be that what? A simple pendulum. Motion of a simple pendulum is a typical example of your oscillatory motion. Also, the movement of a loaded test tube is a typical example. The back and forth movement of a loaded test tube is a typical example of what? Oscillatory motion. So, having said this, we push to the next aspect, talking about circular or rotational motion. Circular or rotational motion. This is actually the motion of a body in a circular path about a fixed point. Remember, when you tie a string to an object and you are whirling it round, there is a fixed point, which is the point with which you are holding the rope. Once you let go from that fixed point, then it is expected that what? You are going to have the rope flying away. As such, the motion of a body in a circular path about a fixed point is what we tag circular or rotational motion. And a typical example would be the rotation of your fan blade. So when you have that what? A fan is rotating, the spinning effect of your fan blade is an example of what? A circular or rotational motion. Why? It is about a fixed point. This is taking place. Having said this, we come to terms with relative motion. Relative motion generally would not be considered among the key major 4 types. We will only consider it mostly when it has to do with calculations. But in essence, what is relative motion? Relative motion is actually the motion of a body subject to the motion of another body, relative to the motion of another body. So a typical example would be this. Imagine a baby strapped at its mother's back. What happens? You have that what? The baby is not moving on its own. The baby is moving subject to the motion of the mother. When a person is seated in a car, driving a car, it is expected that what? Relative motion is taking place. And why is that? You have that the body, the person inside the car, is not actually moving on his own or our own. We have that the person is moving subject to the motion of the vehicle. So, you could also be given questions involving a ship that is actually moving, or a boat that is moving along the river course. And you have that the current of water is also what? Is having its effect on the movement of the boat. Imagine we have a boat that is to cross a river whose current is moving southwards. And you have that the boat I know you can draw better than me, so let's have this as our simple boat. If this boat is to cross to the other end of the river, and we have the current moving southward, the boat is to move eastward, while the current is actually moving southward. What happens? You are not going to have a completely what? 100% eastward movement. Why? The current moving southward will make an impact on the boat. As such, the final movement will be such that the boat will be displaced away from the final destination. There's going to be a displacement of the boat away from the final destination. As such, a boat that wants to get to this point, in real terms and real sense, is expected that if the boat is to start from this point here, and it is to move to this point here, it is expected that what? The boat should journey along this course. in the sense that the boat is to travel upward, such that as the river is taking its course southward, it is going to tilt the motion towards the final destination. So, the motion of the boat relative to the river current is what we tag a relative motion. So now you get a clear understanding as to the types of motion we have. The next aspect will now be this. For you to understand that motion is actually divided into two parts. Motion is actually divided into two key parts. First, we consider motion with respect to kinematics. And we also consider motion with respect to another branch known as dynamics. Now, wake up. In your SS1, you've come across the term Newton's equations of motion, as well as Newton's laws of motion. This is what you should put in mind. Anytime reference is made to Newton's equation of motion, then you are talking about the branch of motion dealing with what? Kinematics. Newton's equations of motion. But the moment you are bringing on board the laws of motion, then understand that you are dealing with the branch of motion which has to do with dynamics. Newton's laws of motion. So your Jamb exam is expected of you to understand in details how exactly kinematics differ from dynamics. How exactly kinematics differ from dynamics. This is what we mean. Kinematics is actually the study of motion of a body without consideration to the force causing the motion. On the other hand, dynamics is actually the type of motion which we study with consideration to the force causing such motion. I come again, I take it again. Anytime we are dealing with kinematics, we are concerned about studying a motion without emphasis, without consideration to the force that is bringing about that motion. As such, that is why you have that what? Any question given to you involving the equations of motion, you are not expected to bring on board anything related to mass or force. Even if you are given in the question, you are not expected to use it. Even if you are given in the question, you are not expected to use it. Why? Mass and force are not needed whenever the question is structured towards the equations of motion. On the other hand, whenever a question is in relation to Newton's laws of motion, then understand that what? We are making emphasis on exactly the force that is what? Bringing about the motion. So having said this, we're going to be looking at kinematics in details, and we'll be looking at dynamics in detail. Let's get right into it. We said kinematics is linked up with the equations of motion. This is what we should put in mind. Anytime we are talking about kinematics, then we'll be considering these four main aspects: motion along straight line, motion along horizontal straight paths. We'll be considering motion vertical motion, vertical upward or downward motion. We'll be considering horizontal projectile motion. Horizontal projectile motion. And lastly, projectile motion. So you might have come across some of these subheadings with respect to your secondary school. You might have seen projectile motion taught as a topic without knowing exactly where it actually falls under. Projectile motion falls among the types of motion with reference to kinematics. Now, when you bring on board dynamics, what are the key things we want to look at? We want to consider the motion subject to the fact that what? Friction can always act on the body. Remember working with the Newton's laws of motion. One of them said, to every action, we must have what? An equal and opposite reaction. Newton's third law says to every action, we are expected to have what? Equal and opposite reaction. And that is where we have friction coming into place. A force is used to propel a vehicle in the forward direction. It is expected to know that what? There must be a balance, a counterbalance, such that what? You are going to have an opposite force in the opposite direction. And unless the force you are using to propel the vehicle is strong enough to overcome the frictional force, then the vehicle would not move. And picking into prospect Newton's second law, we have that what? Force is actually related to the rate of change of momentum of a body. And mathematically, we're able to come up with F is equal to ma. So meaning that what? When you consider the difference in the force acting on a body and acting against the body, it must always be a function of the product of what? Mass and acceleration. We're going to get right into it. Don't be scared. Up here, dynamics. What are the key 4 things we'll be looking at under dynamics? The first is this. We'll be considering dynamics on horizontal surfaces. Horizontal surfaces with horizontal force. We'll be considering dynamics on horizontal surfaces with force at an angle to the horizontal. We're going to be considering dynamics of an inclined plane. So when they ask you questions involving friction on an inclined plane, motion of a body along an inclined plane, then you should know that it is under dynamics. Then also, we want to talk about the dynamics of a lift. So go check your Jamb past questions. You'll see that we have questions involving people ascending up a lift or descending, as the case is. Here we go. We'll be considering the 2 forces that will be acting on that lift, either when moving up or when coming down. So these form the 4 key aspects under dynamics and the 4 key aspects under kinematics. When you are able to actually place them based on where they belong, it is easy to build the confidence as a physics student, knowing exactly, oh, this question being asked is under this topic, and under this topic, it is under this aspect of the topic. Then your confidence increases. It's expected of you to know that what? Your best bet to getting an excellent result in your physics exam is being able to place the questions under the right topics, because that is when you can think specifically to use the correct formula where it applies. Now, take for instance, imagine a question being asked talking about a car moving from rest. When we are making reference to a car moving from rest, we know for certain that gravity will never act on a car that is moving on the ground. Certainly, you won't expect a car to fly at the moment. Not yet. technology has not warranted that to create what? A confusion. So you know that for certain, when we are making reference to a car is moving on the ground. As such, one of the types of kinematics fits in, and that's going to be motion along what? Horizontal paths, horizontal surfaces. Then you can easily apply formulas that relate to horizontal motion. Up next, if you are told that a mango drops down from a tree, you can see that what? For a body to actually drop from a given height, or an object is thrown vertically upward to a given height, then it is expected that gravity is going to act on such body. So expectedly, you should know that what? It will only come under vertical, upward or downward motion. Meaning any formula you want to use in that respect should be aligned with vertical, upward or downward motion. And that creates a clear distinction to the fact that A is the alphabet used for acceleration for what? Horizontal motion. And G, acceleration due to gravity, will be used for vertical, upward or downward motion. Furthermore, horizontal projectile motion. When a body is thrown from a given height and it falls a distance away from the starting point, it is no longer a vertical, upward or downward motion. That now becomes under this aspect, a very simple aspect of what? Kinematics. Let's get right into looking at them one by one. First up, whenever we talk about motion along horizontal surfaces, so this is under kinematics, and we are picking motion along horizontal surfaces. Once it has to do with this, then you apply the fundamental equations of motion, which you have right from SS1, the 4 key formulas involving the Newton's equations of motion. The first is this. We have V as being equal to U plus AT. Yes, what does the second entail? The second is simply S is equal to UT plus half AT square. The next is V square is equal to U square plus 2AS. And the last one is S equal to U plus V in bracket of T all divided by 2. So this form the 4 key formulas which we use under equations of motion as you were taught in SS1. Now, on this note, you must now understand something. That whenever it comes to horizontal motions, there are certain parameters that will be given you in sentence format, which you must always note. And what are they? The fact that whenever you are told that, so note, when a body, it can be a car, a train, a boy, name it. So whenever a body moves from rest, there's a message being sent across to you as far as Jamb is concerned. Whenever a body moves from rest, the word is from rest. There's a starting point. And the moment they're telling you that the body is moving from rest, it means that your U should be equal to 0 in the context of that question. A body accelerates from rest. They're telling you that what? U value should be equal to 0. You already have a value given to you based on that question, although not a numerical value. They expect you to decode that English as being U equal to 0. But whenever you have that what? A body